Hello friends, welcome to my video. In this video I will show you how to design a simple spring mass damping system in a Simulink. So before that I have done some preparation over here, so open option MATLAB. So this is the simple mechanical system most of the electrical engineers would be aware of, and this is a double order differential equation, and the equation I have written below. I have used a notation 2 and 1 here to show that this x is differentiated 2 times. It's due to x by dt square. So I will not go into the details of this equation. I hope you all are aware of it, but in simple way I'll explain that mass into acceleration, that is the end result on this mass which is applied, is equal to the force which is applied minus this damping coefficient into the velocity of this distance minus spring coefficient and distance. So now let's design this equation into our Simulink model. So we open a blank Simulink model. MathWorks provides different templates over here, so I'll choose a blank model because I don't need library, I don't need other stuffs. So once this blank model is created, I will start designing my equation. So I'll just keep it open in parallel. I just need this equation, and MathWorks very many times they say that whatever, if you can write it in an equation form, they can make a model out of it. So we have an equation over here. So now let's start. So there are different people do modeling different ways. The way I do is, since I know here there are 2 times this x has to be differentiated, since we don't have a difference block in library, so we will use this integrator. So I know that I will need to integrate 2 times. One is for this velocity, and second time I will have to integrate this acceleration for this distance. So I put it here. I give initial value. For the timing I just leave the initial value as it is. So if let's assume if our x is here, so this will be x1 or x dot, that dx by dt, and this will be our dx x2 or d2x by dt square, the acceleration of the mass. So now we have got these parameters, and now let's design. So for x2 we need a sum block, and sum block is here, but it has only 2 ports and we need 3. One is for force, second, and this. So I'll just double click this to set the properties. For some reason I prefer this rectangular shape, and the symbols we need is plus, minus, minus. So first is plus force, and then second is minus, third is minus. So we just go with plus, minus, minus concept. Okay, now we put a constant block for force, and so this is our force. I will just name it as F. We will define all these parameters in our workspace later on, and I just connect it to my sum block, and this is my x2. But x2, before going to here, it should be multiplied by x time. So then that will become our x2. So I have to bring a gain block here. Put m. So this becomes our x2. And for x1 and x, so this is our x1, but we have to multiply it by b to get the correct value. So I bring this block here, but I will flip it over here. So for gain I will use b and I flip it. Similarly I do for the last one, which is k, and I flip it again. and yes, so this goes here and this goes here. Same way we can just put this here and here. I'm using a bit of shortcut keys, that control key, so if you're not too familiar you can use it. So this is our x, this x1. We'll also put a scope to see what is happening and how is our equation is behaving. So this becomes one. Okay, so I think we'll save this model. Our model is ready now. I'll save it by the name of spring mass damp model. Yes. Now, before simulating, we will have to give all these initial values in our MATLAB workspace, so that we can give. We have to give, I think, f probably 5 should be fine. So on the right hand side, you can see in the workspace these values will come. So 5 came. Mass probably I'll keep 10. Of course, you can try with different values as per your equation and the expression which you are writing. So here I'm just taking something, and spring coefficient probably say 100, and damping coefficient is probably 10. Let's see what it happens. I'm trying to define an underdamped system, but let me see if that's good enough. So I go back to the model, and those all parameters is what I need. I need f, I need mass, and for initial values I kept 0, so both are 0. Probably let me give some initial value. There is some velocity here, so whatever value you give, that's the initial value of this x1. So that's, there is some velocity, but the displacement from where we are starting is 0. Okay, so now we will start the simulation and see what happens. So it's simulated, and open the scope. Okay, so it seems like not an underdamped but an overdamped system, or critical damp. I mean, it depends upon the settling time and all those things. So let's make it a bit more flexible, this system. So we'll reduce the damping coefficient to say 5 and see what's the effect it is. So we'll go to model and simulate it once again. Yes, you saw there is some spark, it's coming here. So probably you can increase the force rather than going and doing it there. You can also do it here in the constant block directly. So say for example I set it 10, so now I have more force. So let's see what happens. So if you have more force, then also it's just, it has increased from 0.5 to 0.1 but nothing else is happening. Probably we can reduce this, our friction coefficient, from k to 50 and see how it happens. And we reduce our B and mass. So somehow I'm trying to bring it to a underdamped system. I want to see that waves forming here, which I am not able to see, and I think its initial value, it doesn't matter, but it doesn't matter, so I'll keep it like a 0, and I will keep playing with these values. So let me bring this further down to from b equal to 5 to b equal to 2, and now let me see. Yeah, you saw some waves started forming up. I reduce this also further to 20 and see. Okay, so this needs to be high and this needs to be further low. Yes, this is what I wanted. I wanted this kind of waves, and if you see, it's getting settled somewhere around 0.5 here, and that's because of there is a constant force being applied to our mass damping system. So since a force is being applied, x of around 0.5 is the stable or equilibrium position. If you want to quickly check, we can make this force as 0, and now my guess is it should settle down at somewhere around 0. Yes, see, that is what I expected. It's settling down at 0 after going through all this a bit of oscillation along the equilibrium point. Okay, so that's all. Thanks for watching my video. Do comment if you have any question, and please subscribe to my channel to see more videos on MATLAB and Simulink. Thank you and have a nice day. Bye.